All right, here we are. So first couple questions are find the length of a curve, which, come on, cooperate here. There we go. Which the distance formula we talked about in class is the integral from a to b of the square root of 1 plus dy dx, or dx dy, if you use y instead, squared, and then dx out here, or dy, again, if you switch it. So if we're given a ln of sine of x, well, first thing you gotta do is find the derivative, right? So f prime of x for a is 1 over sine of x times negative cosine x. No, times positive cosine x. Cool, which happens to be cotangent of x. That's the derivative. We need to square that, add 1 to it. So we need the square root of 1 plus cotangent squared. Boom. And we want to go from pi over 4. You can tell this is old because I wrote the word pi out instead of putting the symbol for pi. 3 pi over 4. That's basically it. If we use the calculator, we could, work that out. But we're going to do these by hand. So 1 plus cotangent squared happens to be cosecant squared. Okay, that's a Pythagorean identity. We've discussed those. 1 plus cotangent squared is cosecant squared, and the square root of cosecant squared is just cosecant. Well, the absolute value of cosecant, really, but cosecant's positive on this integral, so that doesn't really matter for us at this point. Now, the integral of cosecant is something along these lines. Man, it's been a while since I've done this. Ln cosecant x plus cotangent x plus c. Okay. Is that negative? Oh, this is embarrassing. So, it's the beginning of the year. I haven't looked up integrals in a while. What's the integral of cosecant of x? That's my phone.
Here is information from math2.org.
Ln cosecant, okay. Oh, it is negative. Okay, see, I wasn't sure. Okay. Negative. All right. Oh, not plus. See, look, I'm all over the place here. Okay. Boom. From pi over 4 to 3 pi over 4. And all we got to do is plug in these values. So we get negative ln. Cosecant of 3 pi over 4 is root 2. Okay. Cotangent of 3 pi over 4 is negative 1. Okay, and there's absolute value, but that's positive, so that's okay. So minus the negative ln. We plug in pi over 4. And cosecant of pi over 4 is root 2. And cotangent of pi over 4 is positive 1. So that's our answer. We could put that together and simplify that a little bit, but for right now, that's good enough for us. All right. And most of the time, if you see this anywhere, you're going to be allowed to use a calculator. These questions were designed just so we could handle them without a calculator. So let me grab this one. Just let me grab these two here. We'll do them both over here. So it's B and C. All right. Ba-doom. So for B, same thing. We're going to use the same formula we've been using. So we need g prime of x. So that's going to be 3 halves times 1/3. So that's a half. 4 minus x to the 1/2 times negative 1. Okay, we have to square that. So that's going to kill the square root and make it positive 1/4. So it's going to be, when we square it, we're going to get 1/4 4 minus x. Okay, and we need to add 1 to that. Drop it in a square root and integrate it from x equals 0. Where'd that just go? To x equals 4. That all simplifies down if you distribute the 1/4 to the integral from 0 to 4 of the square root of the 1/4 and the 4 become a 1, so that's going to be a 2 minus 1/4 x dx. So the integral of that is going to be, that's to the 1/2, so we're going to get 2 minus 1/4 x to the 3 halves, right, times the 2/3 by the power rule, but also times a negative 4 by the chain rule. Yeah, because when you drive that, you're going to multiply by negative 1/4, and that's going to delete that out there. So you can also do a u sub there if you wanted to. From 0 to 4, so out front we're going to get negative 8/3. And when we plug in a 4, we're going to get 2 minus 1, which is 1, to the 3 halves is 1. Cool. Minus, when we plug in a 0, we're going to get 0, so 2 to the 3 halves. I don't really like that. Really? Okay. 2 to the 3 halves is what? Square root of 8. So that's 2 root 2. Okay. And the negative could distribute and simplify that out, but that's all we need to do right there. That's our answer. All right. What was C? I'll do C up here. So first again, so C, we're going to derive it. So y prime is x cubed over 4. Nope, over 2. Boom. Cool. This is really 1/4 x to the negative second, right? So we're going to multiply by -2, so it's going to make it -1/2 x cubed. All right, and we need to square this ridiculous thing. I'm just going to tell you guys to use a calculator. We can do this by hand. Okay, I'll do this by hand real quick, but we can just use a calculator from this point out. But we're going to square this. Okay, now we're going to have to, it's a binomial, right? So we need y prime squared, really. So I'm going to square this. Well, that squares the first thing. So it's going to give me x to the 6th over 4 minus the middle term is then multiplied together and doubled. So when you multiply those together, the x cubes cancel and you get a 4th. But you're multiplying, you're doubling that, so you really get a half here. And I'm just using this rule here, by the way. If you, the erase button on this new pen is so hard. Okay. When you do this, you get the first thing squared, which is x to the 6th over 4, minus 2 times both of them. That's that half right there, plus the last thing squared. So that's going to be plus 1 over 4x to the 6th. So you can see that this is what happens with this. And now we need to add 1 to this too, okay? So keep that in mind, and we're going to drop that into square root. But the common denominator that we would get here is going to make this all come together is 4x to the 6th. So we need to do x to the 6th here, x to the 6th here, right, to make that happen. We need 2x to the 6th here, and 2x to the 6th here, and this is already 4x to the 6th. So this is going to become x to the 12th minus 2x to the 6th plus 1 all over 4x to the 6th. That's the derivative squared, and I need to add 1 to that. Okay, so technically we're going to add 1 to it, drop it in a square root, integrate it, dx. I'm going to do that over here neatly, but that's what we're doing. But 1 is really just, if you think about it, right, 4x to the 6th over 4x to the 6th. So we put all this mess together. We're going to have the integral from whatever numbers I chose, 0 to 4, of the square root of x to the 12th plus 2x to the 6th plus 1 all over 4x to the 6th. Shoo-hoo! And it turns out, dx, check this magic out. Turns out that that numerator is a perfect square. Okay, and that's why we chose this question, so we could do it by hand, because otherwise the square root makes things kind of complicated. But that numerator is actually just x to the 6th plus 1 squared. The denominator is really 2x cubed squared, and they're both in a square root. So what that becomes is the integral from 0 to 4 of x to the 6th plus 1 over 2x cubed. That's really what's going on there, because the squared roots cancels out the squares. Okay. And then we got to simplify this a little more. This is super fun. We can bring the 1/2 out front. Right? Remember that? That's 2 right here is all multiplication. Just drop them out front. X to the 6th over x cubed is x cubed. 1 over x cubed is x to the negative 3rd dx. So we're going from 0 to 4, and 0 is going to be a problem here. Is this thing not even defined at 0? Come on, Mr. Smith. Oh, it is. Huh. We got this negative 3rd in here, though. So I try to plug in 0, it's gonna cause some problems. Why is that happening? We're gonna get 1/2. Yeah, that happens here. What's gonna happen? Oh, because I'm doing part C. It's from 1 to 2. That's why. I'm like, why would I make a question like this? These are all from 1 to 2. All right, so let me erase all these. Gosh darn it. 1 to 2. Here you go. Hey, what's happening? You were in a calculus video at this very moment.
Why did you answer?
Well, because I want to say I'll call you back. That's all.
Okay, call me back.
Bye. Okay. That's my friend. So we're integrating this, and x cubed is going to become 1/4 x to the 4th. This becomes add 1, -2, but that's going to put a -1/2 out front, right? Now I'm all over the place. Okay, so we got that, right? Add 1, divide by 4, add 1, divide by -2. Boom. Plug in a 2. Look at this math. Just plug it. This would have been way nicer in a calculator, but you plug a 2 in, and you get to the 16th there, 1/4 times 16th, which is, 4? Boom. Minus. Drop a 2 into there, you're going to get an 1/8. Minus, when you drop a 1 in, you get 1/4. Minus 1/2. Might as well simplify that out, right? So this becomes 4 minus an 1/8. Was that 32/8? Take away 1/8 is 33/8. Minus 1/4 minus 2/4 is -1/4, but we're subtracting that, so it's really plus 1/4, but that would be plus 2/8. There we go. That's 35/8 times 1/2. And the answer everybody wanted to know, yeah, 35/8 times 1/2 is 35/16. That is the arc length of that incredible curve. Okay. My goodness gracious. I'm using a calculator for the rest of these. Actually, I'm just going to get to the integral part of it, and that's about it. I assume you can all plug them into a calculator. This is just a line. We could use the distance formula for this, honestly. Actually, that's what I'm going to do. So you try and set up the integral, okay, and you can try that by hand because that's not too bad. But because it's just a line, a straight line, distance on a straight line is just the distance formula. So we need to know the points. So when x is 0, y is going to be -2. And when x is 1, y is going to be 1. So we need the distance from 0, -2 to 1, 1. And remember, all the distance formula is, if you draw this out, 0, -2 is down here. And 1, 1 would be like right here. It's just Pythagorean theorem right there. That's all we're doing. We're finding that distance between those 2 points. So we have a distance of 1 here, and we have a distance of 3 here. So by Pythagorean theorem, 1 squared plus 3 squared has to equal my distance squared. So we'll put that in a square root, but what's that? 9 plus 1, 10. So the arc length there, which they usually call S, I used S or D, but that's an S, not a 5. Okay, is root 10. Okay. And here, to do this, we'll drop this one into a calculator. Oh no, I'll just write the integral out. When you derive this, you can see I'm all over the place. I'm trying to hurry. It's late. It's not really that late. It's 4. It's almost 5, but I got stuff to do. It's 2/3 x to the -1/3. So it's 2 over 3x to the 1/3. We're going to square that, which makes it 4 over 9x to the 2/3. We're going to add 1. We're going to drop it in an integral. We're going to put a dx at the end, and we're going to integrate it from 1 to 8. There you go. Not too bad. All right. Verify the circumference of a circle. What a good question. Is 2 pi r? Well, we can do this a couple of ways, but what was that? But the easiest is to do this. So everybody knows that the equation of any circle in the xy plane centered at the origin is x squared plus y squared equals r squared. Okay. Now to find the arc length, I need this in terms of y. But what that will give me is this graph. Well, that's r. Okay. So when you solve that for y, you get plus or minus the square root of r squared minus x squared. Okay. Now it's plus or minus because there's a top and a bottom to that. So let's just find the arc length of the top. How's that sound? Okay. Find the arc length of the top. And then that should become half the circumference, which would be pi r. If that's true, then the whole circle is 2 pi r. So to find the distance around the top up there, so we're just going to use the positive version of that. I need dy dx, which is, we're driving a square root, which is always 1 over 2 times the square root of the inside times the derivative of the inside, which is -2x. So these 2's cancel. Goodbye. We have to square that bad boy. So that becomes x squared over r squared minus x squared, cancels out the square root. We're going to add 1 to that, okay? But I'm just going to go ahead and make that 1 a r squared minus x squared over r squared minus x squared. We're actually just adding 1. That's our formula, right? Derive it, square it, add 1, put in a square root, dx integral. Now we want to integrate and find the circumference. So if that's r, this value over here is negative r. So we're going to integrate this from negative r to r. I could also do 0 to r, and that would just give me a quarter of the circle right here. So that should be pi over 2. R, yeah. But anyway, if we do this, we should get pi r. But you see this simplifies all the way down to this, the integral negative r to r. The top, the x squareds are going to cancel. So all we have up top is r squared. But it's in a square root, so all we really have up top is an r over the square root of r squared minus x squared. And everybody remembers from last year, a squared minus x squared in the denominator in a square root like that, if there's no x's on top, becomes, so the r is there because that's the r that's like sitting right here on top. The integral actually becomes arc sine of x over r. And then we have to divide r. Oh man, I should look these rules up. I don't think we do divide by r. I think it's just that. Yeah, it has to be just that. Okay. So that's that integral that's sitting there. We did that last year, I'm fairly sure. If not, that's a rule we'll talk about this year. And we'll go from negative r to r. When you plug in r, you get arc sine of 1. Well, guess what that is? It's pi over 2. Minus, when you plug in negative r, hey, minus. When you plug in negative r, you get arc sine of negative 1. Well, guess what that is? It's negative pi. It's not right. It's negative pi over 2. Boom. Well, that happens to be pi over 2 minus negative pi over 2 is actually pi. So this answer is pi times r. But that was only half of the circle, which proves the circumference of a circle is 2 pi r. You're welcome. That's incredible. Oh my gosh. Okay. Let's go back over to wherever this worksheet was. There it is. Okay. Oh, okay. 3 says approximate the length of root x from 1 to 4 using the trapezoid rule. Let's cross this out. We don't care about the trapezoid rule. Let's just find the actual value of it. I made this up one year and I wanted kids to remember the trapezoid rule, but I don't feel like going through all that junk right now. All right. So you would derive it. You would square it. Actually, look, this is the same exact thing as this right here. Okay, except that the limits are different. So you derive it, which would give us 1 over 2 root x. So that's y prime for this question. And question A in the next part. We're going to derive that, or square that, which gives us 1 over 4x. Nope, 4x. Add 1 to it. Drop a square root in there and integrate it from whichever question we're doing. We can go 1 to 4 or 0 to 3. I'm going to do 0 to 3 because I'm going to skip that other question. And if you put that into, actually that's just the answer because it just says right the integral. Okay. The other one would be from 1 to 4. All right. B, I put some y's in there to make it look a little scary, but it's really just the same stupid thing because I'm giving you the y values that I want you to find the length of. So B of what? B of this is going to be the derivative, which is f prime of y equals y squared. Cool. We're going to square that, so we get y to the 4th plus 1 in a square root dy integral from 0 to 2. That's it. You're done. Okay. Part C, I'm going to do right here. We need to derive it, which is 2x. We need to square it. That's going to be 4x squared. We're going to add 1. We're going to put it in a square root times dx. And we're going to integrate that from 0 to 1/2. Okie dokie. For D, we'll do D down here. We need to derive it, but before I derive it, I'm going to distribute that stupid root x, and then I'll feel like dealing with that. So 1/3 root x times 3 is root x minus 1/3 root x times x is 1/3 x to the 3/2 power. All right, so that's easier to derive that way. So dy dx is going to be something, 1 over 2 root x. We're going to subtract from that the derivative of that next part. 3/2 times 1/3 is 1/2 root x. Okay, this is similar to the one I did up top there with the x to the 3rd, where I had the wrong limits, because this is one we can do by hand, but we're not going to do this by hand. So that's the derivative. And look, on a test, honestly, boom, this is 1 plus that derivative squared If you have a calculator, you can just do it all on a calculator. Squared dx, integrate from, what do they ask us to do here? 0 to 3. Cool. And then the very last one, which is numbered 1 instead of E for some inexplicable reason, but it's a PDF and I'm not changing it. Not the best grab there. Kaboom. All right. So we have, find the length of this curve. Let me just draw this down here real quick. Ba-dow. Now, the problem with this is we don't have y or x by itself. We need to get one of them by itself. Well, it sure does make sense to just subtract the 1 off and write this as y equals 4 root 2 over 3 times x to the 3 halves minus 1 and derive that. So the derivative of that, dy dx. So we multiply the 3 halves down, the 3's cancel, and the 4 and the 2 cancel, and we get a 2 root 2 x to the 1 half, which maybe seems a little bit scary, but we're going to square it. So 2 root 2 squared is 8. X to the 1 half squared is x. We're going to add 1. We're going to put that in a square root dx. Now, look what I did to you. I'm so sneaky. I gave you these values, but those are y values. Oh, no. So we could have solved this thing for x, and then we'd have the limits because we'd have y in our integral. Okay, but we solved it for y, so now I got to find out what stupid x is. So if y is -1, that makes this side here 0. But if this side here is 0, then this side here has to be 0. Okay, and the only way for that to happen is if x is 0. So we have this point here, 0, -1. That's when y is -1. And 13/3. If I put 13/3 in here for y, I need to do 13/3 plus 1, which is 3/3. So that's 16/3 equals 4 root 2 over 3 x to the 3 halves. Now you solve that, we're going to multiply 3 over. That's going to cancel out the 3's. We're going to divide by 4 and a root 2. So we're going to get 4 over root 2 equals x to the 3 halves. Right? Yes. And we can rationalize that if we wanted to. Actually, root 2, that's just 2 root 2 is what that is. Okay. And to get rid of 3 halves, I need to raise to the 2/3. So that means we're going to square it and then cube root it to the 2/3. But if you square 2 root 2, you actually get 8. And if you take the cube root of 8, you get 2. So it's just x equals 2. So we need to integrate from 0 to 2. And that's going to give us the answer we want. It says find it, but I'm just going to write the integral. And not too bad.